So we're starting our final unit of the semester here. This unit, we're going to take this trig that we've been talking about, and we're going to apply it to the areas and the volumes that we saw during that first couple weeks of the semester. So today, just a little review of area of triangles first. If I wanted to find the area of a triangle, of course, a right triangle is the easiest one to find the area of. Let's say I've got a triangle that's 15 feet by 8 feet. How do I find its area? You got it. Base times height divided by 2. Because you're going to go 60 square feet. But what if it's not a right triangle? What if it looks like this? Does it matter if we know this dimension here? Say no. What do we need to know? We need a dimension perpendicular to that base. We need to know this dimension here, which is what we call the height of that triangle. And the reason it's called the height is it would be the height of that corresponding rectangle if we had the full rectangle. If we're given that height, wonderful. But if we're not, there are ways we can find it. For example, let's say that we are told that this side is 8 feet and that this is 62 degrees. How would I find that height? Well, according to this 62-degree angle, this is a right angle here, so we have a right triangle. According to that 62-degree angle, what side is H over here? Opposite. And of course, the 8's the hypotenuse, right? What trig function uses opposite and hypotenuse? Sine of an angle is opposite over hypotenuse. So the sine of 62 degrees, that's the hypotenuse. That's this side right here. So sine of 62 equals h over 8. Put that over 1 and we cross multiply and divide. Well, it's just 8 times the sine of 62. Divided by 1 doesn't do anything. That's h. So the area of this is going to be the base of 18 times the height, which is the 8 times the sine of 62. Then, of course, divided by 2. 63.57, and that is square feet. What's that? I put 4 instead of 8, but then I didn't divide by 2. I was just being lazy on how many buttons I had to hit. Oops. Scroll back up by accident. There we go. So the formula is, if I have a triangle, 5-7. So if I have a triangle where I know 2 sides, let's call them sides A and B, and the angle in between them, which we'll call angle C, obviously, because these are the same things we needed to use the law of cosines, aren't they? 2 sides and the angle in between them. The area of that triangle is going to be A times B times the sine of angle C over 2. So let's take a peek. So to find the area of this triangle, what am I going to do? Perfect. 42 times 53 times sine of 112 over 2. 42 times 53 times sine 112 divided by 2. 1031.96. What's that? What do you mean the sine's the opposite? Sine is opposite of hypotenuse, but we're not worried about that anymore. We're just worried about the sine as the trig function for right now. Oops, what happened? Somehow I fast forwarded like 20 pages there for some reason. So there we go. 1,031.96 square feet is what you come up with. Sound right? So it didn't matter that that's an obtuse angle. It really doesn't matter. It's just whatever that angle is. You take its sine times the two sides and divide by 2. So how do I find the area of this? Can't use tangent because there's no right angle. No right angles. Remember, area but do we have two sides and the angle in between them? No. Yes. Now I'm going to tell you that this is an acute angle right here. Why do I have to tell you that it's acute? Because otherwise it screws everything up. So if we know that's acute, we've got 27 over the sine of 46 equals 39 over the sine, we'll call that angle B up there, or sine of B. We cross multiply and divide. Sine of 46, close parentheses, times 39 divided by 27. Oh, what are you getting wrong there? It's not a triangle. That's bigger than 1, so we can't do it. That's saying this side's too short. So there is no area. It's not a triangle. So let's try this one. I'm going to label it A, B, little a, little b. No, I did that for a reason. I put that out there for a purpose, to recall that sometimes you don't have triangles that fit. So on this one now, do we have two sides and the angle in between them? No. I have these two sides, but I really need this angle. So I've got my 43 over the sine of 84. But the 32 is going to go over the sine of A. That's this angle. Not really the one I want, but that's where I got to go for now. So I'm going to cross multiply and divide. Sine of 84 times 32 divided by 43 is 0.7401. So A equals inverse sine. That sounds about right, though. 4774. So then we got to subtract to get this one over here, which is going to be what? 4826. Very good. So now we can find the area. 32 times 43 times the sine of 48.26 degrees over 2. Gives us 513.37. That is feet squared. Good stuff. Not yet. Don't get antsy. How about this one? How do we do this one? I need either this side or this side, don't I? How do I get one of those sides? Yes. 57. Does that help? 20 over the sine of 57. Yeah, which side do you want? This one or this one? This one? So that over sine of 41. So 20 times the sine of 41 divided by the sine of 57. Now, a lot of people screw up because they start just trying to punch these in their calculator without writing them out. I have a hard time getting them in the calculator in the right order without writing them out like this, at least first. So we got what? 1565. Feet, so the area is 20 times 15.65 times the sine of 82 over 2. Giving us 154.98 square feet. Yes, no, cool. Find the area of this one. Crossbow. So 20 over the sine of 29 degrees. I'm going to label my angles here. So that'd be 34 over the sine of C. You got it. So sine of 29 times 34 divided by 20. And then inverse sine tells us that C is 55.5 from 180. 55.51. So 180 minus that gives us 124.49 degrees. So now that we know that's 124.49, we can find this one over here as being 36.51 degrees by subtracting them all from 180. That's 26, not 36, isn't it? 26.51 degrees. We need that angle to find the area, though. So now the area, 34 times 20 times the sine of 26.51 degrees, all over 2. Giving us 151.76. Because that is the one that was between my two sides. I got this side and this side, angle is between. So how many people got 151.76? How many people got 151.76? Close enough. Okay. So now, there you go. What if we have a parallelogram? And we have this angle here of 71 degrees. We can do this. Cut it like that. What do we have? Two triangles, right? What's the area of each triangle? 18 times 40 times the sine of 71 divided by 2, right? Well, since there's two of them, we just don't have to divide by 2. Yeah, so it's 18 times 40 times the sine, 71. 680.77. 77. Come on. So how do you find the area of this one? What's that? Nope, don't have to make it a 90. Nope. We can find the area of this triangle right here. But we need to know this angle. What's that angle going to be? How do I know it's 48 degrees? Because if that line and that line are parallel, these two have to be supplementary. So it'll be 20 times 50 times the sine of 48 degrees. Do I divide by 2? No, because there's two triangles there. So 20 times 50 times the sine of 48 is 743.14. What do y'all think? Better than a sharp stick in the eye?